So RF exposure. Last time we talked about basic electricity, AC, DC, how we protect ourselves, keep from getting shocked and all that. So now we're going to go on to RF exposure and how we can keep safe from over RFing ourselves. It's actually pretty easy. RF exposure is not hard to protect from. Well, it would take a lot of RF exposure, like more than our transmitters are legally capable of producing, unless you're doing moon bounce or something with, very high frequency and, megawatts of RF energy coming out of your antenna. We'll go through this. It's necessary. You need to know the background, but don't sweat it. Generally, when you do the RF calculation for exposure, you're going to find your way under the minimum requirement. So, yeah, don't get radiated. The RF that we transmit is non-ionizing RF, and we'll talk about that. But what it does is produces heat, and it begins to damage the cells because it's overheating the cells, just like sticking your hand in a microwave. Radio waves are a form of non-ionizing radiation. RF radiation doesn't have sufficient energy to cause genetic damage. Pay attention to what's in yellow. You might want to take notes on that. So radio waves, most radio waves, are not a form of ionizing radiation. For the test. Hello? RF radiation does not have sufficient energy to cause chemical changes in cells and damage DNA. That's most RF. That's the RF that we use.
No, that's the question.
That's the question. All stations with a time averaging transmission of more than 1 milliwatt are subject to FCC rules on RF exposure. RF exposure risks vary with frequency and RF power. So increased caution is dictated at some frequencies more than others due to the way the human body absorbs the RF energy. So the human body is about 6 feet tall. I'm not, but that's average. And that length is about 2 meters. So between 6 meters and 2 meters, that's going to be the range for maximum sensitivity to the human body, because that's where we're sensitive. Organs in the human body, our heart, those smaller organs, they're going to resonate at a higher frequency. So some parts of the body will resonate for frequencies other than 6 meters and 2 meters. RF energy and frequency exposure, non-ionizing and ionizing. So from here you can see power lines. Okay, your power lines are what frequency? What's the frequency of power lines?
60 kilocycles.
Not you.
60 hertz. 60 hertz.
60 hertz. Okay, so it's vibrating at 60 hertz. Pretty low. That's when you convert that to audible frequency, you can hear it. And then it goes up from there all the way to visible light. At ultraviolet, so ultraviolet, that's the upper level of visible light. Hey, that's what gives you a sunburn, right? And if you're getting enough of a sunburn, what happens? Eventually, over time, you have skin cancer. Well, why do you have skin cancer? Because it's ionizing radiation. It's wrecking your cells. It's actually changing the way the cells replicate. And that's cancer. That's skin cancer. So same thing with gamma rays, X-rays. You get enough of it, and it changes the replication of one cell to another. And again, where depending on the band, it resonates with different parts of the body. RF exposure and frequency. When body parts act like antennas, those parts absorb RF energy at certain frequencies more efficiently and increase risk. So our body, mine is just under 2 meters high. So at the 2 meter frequency we operate on, my body acts as a pretty good shield. If I've got my HT and I'm trying to determine where the signal's coming from, if I use my body as a shield, I can tell just from how the signal drops. And it's because the body's absorbing some of that RF. Touching an antenna while transmitting can cause RF burns to the skin. Yes, if you touch it at the wrong place. So it'll cause RF burns if you're touching the high voltage point of the antenna. If you're touching some other part of the antenna, yeah, you might get a little tingle, but you won't notice it. RF exposure risk also varies with frequency and power level of the RF field. So again, depending on the frequency and the power level, you have more or less exposure. And distance from the antenna. And that makes a huge difference because just like light, RF dissipates with the square of the distance. So you go, 6 feet away, it's X. You go 12 feet away, it's, X divided by 4. It really drops, and it drops and drops and drops like that, exponentially, not linearly. Radiation pattern of the antenna. So some antennas, like these over here, are omnidirectional. Doesn't matter where you are around that antenna, you're going to have the same radiation pattern. Others are beam antennas that focus in one direction. So with those, you need to be more careful where the beam is focused. Exposure to high levels of RF can cause problems. However, if precautions are taken, RF exposure is minimal and not dangerous. And generally ham radio operators tend to be old people. Maybe we live to be old. If it were really dangerous, we'd all be dying young. RF energy can heat body tissue. Yes, we talked about that. Heating depends on the RF intensity and the frequency. The higher the frequency, the more absorption. RF exposure duty cycle. What is duty cycle? Did we talk about duty cycle?
Yeah.
Helps you determine safe RF radiation exposure levels. Duty cycle is how often the transmitter is on in any given time. So if somebody's operating net control for a repeater and they're transmitting half the time and not transmitting half the time, that's a 50% duty cycle. If the transmitter itself is FM, that's a 100% duty cycle for that transmission. If it's single sideband or AM, you're only transmitting at full power when you're speaking into the microphone. So when you pause between words or even between syllables, there's no power going out. There's only power going out with single sideband if you're talking into the microphone. With FM, however, it's on all the time. As long as you're pushing that push to talk button, it's transmitting. Whether you're talking into it or not, it's transmitting. And that's a 100% duty cycle. So with FM, there's more of an exposure than there is with single sideband.
Depending on how long you talk. So.
Yeah, if you talk really fast, you can say, oh, you're talking to the microphone really quick. Yeah, then it's 100%. So the duty cycle affects the average RF exposure of people to RF radiation. RF intensity, the frequency, the actual transmitter power. The higher the power, the higher the risk. Antenna gain and proximity all have an effect. So if you've got a vertical antenna, or maybe it's an HF vertical, and it stands 40 feet tall and starts at the ground, the highest RF exposure is going to be right next to the antenna because it's all the way down to the ground. If that same antenna were up on top of the roof, you probably wouldn't have to worry about it. Most of the radiation is going out horizontally, right at the horizon. Very little is going down, very little is going straight up. So you could probably get away with quite a bit more power. So beam antennas focus the available energy, and they're beaming. They're pushing it one direction and sacrificing in the other directions. That's the only way it works. There's no free lunch. You don't get more power in one direction and keep all the the power going out in the other directions. You're reducing it to the back and the sides and squeezing it towards the front.
We'll explain that a whole lot more detail down the road. After
Yeah.
you understand what radios are.
Right. And emission duty cycle, the transmitter is not at full output power all of the time, depending on the mode. I just got into that a little bit. Typical duty cycles, single sideband, unprocessed is 20 to 25%. What they mean by unprocessed, there'll be a little button or dial or a knob on the transceiver, especially an HF transceiver, for compression or processing. That means and advertisers do this all the time. They compress the speech to get the highs and lows to average out so they're all high. So normal speech has up and down. We trail off at the end. We may emphasize something and then back off. By compressing it, even the times when we trail off are brought up to one level. So you get this monotone like that, and that's the way advertisers come across. They're coming across to get your attention. So that's compressed speech. If you use unprocessed, your duty cycle is about 20 to 25% on single sideband and about 40% on processed single sideband. So almost double. FM is 100%. Like I said, you push that push to talk button and it's transmit all the time, full power. Now, your rig will have different power settings. So you can bring the power down, from 50 watts to 25 watts to 10 watts, maybe 5 watts. So if you don't need to be running it all the time, don't. Use the least power to get across. You don't have to run full power all the time. All that does is stress the final amplifier. And CW, 40%. And digital, 100%. 100% for digital? Yeah. Yeah. Digital is under sideband. It is modulated signal, but it's modulated right at 100%. The intensity of the RF energy is called power density. So higher transmit power means higher power density. Higher antenna gain also means higher power density. Ham radio operators like to combine those two.
Yep.
More power and directing the signal gets you more contacts.
We even buy very expensive boxes in the thousands of dollars just to get more power.
Well, the whole idea is to be,
I don't buy one.
Yeah.
I believe that that's just a bad operator has to do that.
well, yeah, and then once you've made contacts with all these countries, and then you want to do it low power, and you guys intentionally drop their power to like 10 watts or less and try to get all those countries again on 10 watts. Absorption and limits. Specific absorption rate is SAR. That's not search and rescue. That's specific absorption rate. The rate at which the body absorbs RF energy varies with frequency and size of the body part. The range of highest SAR is 30 megahertz to 1.5 gigahertz. Yes, that's a pretty broad range. Torso and limbs, highest at VHF. The head, highest at UHF, because it's smaller than other body parts, and so it resonates at UHF frequency. 300 to 3 gigahertz, 300 megahertz to 3 gigahertz. Who can tell me what a gigahertz is? So if you've got 1,000 megahertz, that's 1 gigahertz. So 3 gigahertz is 3,000 megahertz.
And I believe your router at home is 2.4.
2.4 gigs.
Right in there.
Yep,
And your 5G is above that.
right.
So, but very short range.
Will you say that again? 1,000 is what?
So 1,000 megahertz 1,000 of these is one of these.
Yeah, we will get more specific with a lot more detail.
Right now-
later in the class.
Right
Yeah.
now, we're gonna just talk the safety part, so we're hitting some things that you will get more in depth later.
Right. Eyes are highest at microwave frequencies. And microwave, you know, it starts around what? 1 gig, about 1 gigahertz. And amateur bands, we have amateur bands well up above 1 gigahertz. So if you get the right equipment or build the equipment, yep, you can operate up there. Because SAR varies with frequency, so does the maximum permissible exposure. Okay, that's the upper limit of safe exposure that that they say you're allowed to expose yourself to. Where SAR is high, maximum permissible exposure is low. Does that make sense?
The bottom line is try and stay safe with RF energy. It will hurt you.
Yeah.
It used to be, there were exemptions for certain bands, 2 meter, the one we use the most commonly when we're getting started. But it's now a requirement to do.
Is this coming from your antenna only? Is that what you're saying? Like-
Right. It varies depending on the antenna type you're using and how far away you are from it.
So there's a whole lot more details to the transmitters and the antennas, but you can get what we call gain, which increases. So you put out 100 watts and you've got a gain, you can increase the effective power going out if you have.
We'll get into
So
a lot.
there's a safer, there's a,
Safe power level and distance. Based
from
on
the antenna.
Yes, yes.
And calculating
Could
it,
be an issue coming through the wall of your house then, or no?
It can.
It can,
You
okay.
can.
and again, it depends on the frequency. At HF frequencies, that'll penetrate the house easily, but at those frequencies, it's not a problem. The body doesn't absorb that energy as readily. At VHF, UHF frequencies, those frequencies don't penetrate as well, but the body absorbs it more. So, you know, you just balance it out. The calculations are easy to do. The ARRL has a calculator page. You just plug it in. You know, it works it all out for you. All you have to do is plug in the values. So the adult human body is resonant at about 35 to 70 megahertz. That's one of the questions. And what does this represent? 35 to 70 megahertz is about 52 megahertz is 6 meters. So they'll ask maybe, is 6 meters something you need to worry about? Yes. Smaller body parts are resonant at higher frequencies. The safe maximum permissible exposure levels are based on demonstrated hazards in the frequency range where the human body is most vulnerable. There we go. 50 megahertz has the lowest value for maximum permissible exposure limit. And again, you know, we usually don't transmit super high power on 6 meters, and we aren't usually using a mega beam or anything on 6 meters. So it's not something to really be obsessed about, you know.
And if you're worried about it, just get some tin foil and
Yeah.
wallpaper.
It's a good excuse. Don't mislead them this early in the class, Bruce.
Near this frequency, the body is most resonant. And again, it depends on the size of your body. A bigger guy will be more resonant at 6 meters than a smaller guy. RF exposure, a lower transmitter duty cycle permits greater short-term exposure levels. Time averaging, with a 6-minute averaging time for exposure, 2 times the power density is permitted if the signal is present for 3 minutes. Does that make sense? So normally, say you're transmitting with FM. It's on all the time. You're transmitting for 6 minutes continuously. You could double the power density if you cut that time to 3 minutes. Just makes sense. So you got the same average power, and the signal is absent for 3 minutes. So that's all they're talking about here, rather than the signal being present over the entire 6-minute period. If the duty cycle changes from 100% to 50%, the allowable power density for RF safety increases by a factor of 2. It's basically saying the same thing, but instead of over time, they're talking about the duty cycle. So if you go from FM, which is 100% duty cycle, to say CW or compressed single sideband, which is 40%, you could more than double the RF safety factor. It's almost never an issue. Like I figured it out, I figured out worst case scenario would be, for me, operating at 10 meters with 500 watts output, and the vertical in the backyard is,
At ground level.
excuse me?
At ground level.
At ground level, the vertical is in the, all the way up the pine tree, and it's at ground level. And it's approximately 25 feet from the house. No problem. Even at that close proximity, it was well within the limit. I could get within 6 feet of it.
Don't let the calculations intimidate you, because it's really easy to take
Yeah.
a couple of minutes.
Yeah. Averaging and duty cycle. Exposure to RF is averaged over specific time periods, and the body responds differently to long duration and short duration exposure. And I think all they're saying here is that if you're exposed continuously, even or intermittently, but over a long period of time, it can have the same effects as one short massive exposure. Different environments are averaged over different time periods. Controlled environment, uncontrolled environment, controlled environment, areas where occupants are aware of and knowledgeable, exposure averaged over a 6-minute period. Uncontrolled environment, areas accessible to persons unaware of the RF exposure. The exposure is averaged over a 30-minute period because they expect people to be there longer and not know.
It's the not know that's the issue.
Yep.
And
they
there's
have
no yellow on these
limits.
slides, notice.
The more time the transmitted power is at high levels, and the greater the duty cycle, the greater the exposure risk. So, when you've got that FM super duper transmitter that will do 80 watts, and you're keeping it at 80 watts all the time you have it on, then that's 100% duty cycle at 80 watts, and you're transmitting with the antenna on the back deck of the trunk of the car. That's a high exposure risk, that level. Put that antenna up on the roof and lower the power. Operating duty factor of modes. So again, conversational single sideband, 20 to 40%. Single sideband TV is at 100%. Voice AM modulation, depending on the modulation, 50 or 25%. And way at the bottom, conversational CW, 40%. Carrier is 100%. No speech processing, speech processing.
So speech processing doubles your duty cycle on the sideband. Up to double.
What is speech processing?
So
Speech
again,
processing
speech
is-
processing is compressing the speech to kick it all up at a fairly high level. Why would we want to do that? Well, there's a DX station from Zimbabwe that is coming in, but it's very weak. And we know if he's weak, he's probably not going to hear us very well. So we crank up the power as far as we can go, and then we kick on the speech processor too, so that we'll get as much power into the transmitter and the antenna as we can. The station licensee is responsible for ensuring that no person is exposed RF energy above the FCC exposure limit. And again, generally our stations are well within the limit. We don't have to worry about that. Every station must perform an RF evaluation for each frequency, mode, and power level. The only time we might have to redo it is if we change our antenna, change the transmitter, put in an amplifier so we've got higher output power. Then
Change the coax, anything that you change on this station.
Yeah, even at lower power levels, an evaluation is required. Yeah, and there's the calculator. ARRL.org, RF exposure calculator. You plug that in.
And it really is very easy to use. You plug in the data from your station, it spits out an answer.
And relocating the antenna. Regardless of the evaluation results, make sure people cannot come into contact with your ground-mounted antenna. RF burns are painful.
And the problem is that RF tends to create a burn tunnel in your flight,
Yeah.
which means that it's going to go on for a couple of weeks.
This stuff's nothing to be afraid of. They really, really push on this stuff.
Yeah, they do.
But it is
It's-
worth being cautious.
You need to know it's out there, it's an issue, but as a technician or a general, unless you're getting real serious and spending thousands of dollars on amplifiers and beam antennas, you aren't gonna get into the realm where it's dangerous. But you can.
So question, are you just saying that the RF exposure, the burns, only does the surface, or does it go full depth?
Oh no, it goes full depth. So it can go right down to the bone and then travel through the marrow. But that's an extreme case, okay?
One of the guys used to tell a story about one of the guys on the ship with him, who, it was cold and he was on watch, and so he stood in front of a radar dish. And it kept him warm.
Yes, it did.
And he still, it was being microwave basically, except with a big outside antenna. But it kept him warm.
Yeah, there were guys, you know, they started using radar in World War II, and back then they were unaware of what the effects were of radiation exposure. And yeah, guys had problems back then because they were working on here where they didn't turn off the radar. Okay, what is PEP? Peak envelope power, defined as the highest envelope power supplied to the antenna transmission line by a transmitter during any full undistorted RF cycle. So it's got a sine wave. That's how the RF works. You've got a sine wave. And at the peak of that sine wave, that's the peak envelope power, the highest envelope power. At single sideband, that depends on your voice going into the microphone, and because it's amplitude modulated, the better the modulation, the stronger that modulation, the higher that peak is. But we have limits to what that can go to. Station compliance evaluation, methods of evaluating RF exposure include calibrated field strength meter with a calibrated antenna. You won't find amateurs using that because it's an expensive piece of equipment.
Right there.
Calculate based on FCC Office of Engineering Technology Bulletin, and the ARL bases their calculator on that. Or you can use computer software modeling to basically estimate. So, perform a routine exposure evaluation to ensure compliance. They're going to ask that. If your station exceeds permissible limits, you have to take action to prevent human exposure to RF fields above the maximum usable limit. If your evaluation reveals your neighbor may receive higher than permissible RF exposure from your directional antenna, take steps to ensure the antenna's main emission lobe cannot be pointed in their direction. Again, this almost never happens because if you happen to have enough property where you can put up a big array and really get out enough power, you've probably got it on an antenna that's at least 60 feet tall.
And you probably got more than just a little postage stamp lot too.
Yeah.
And the key to this slide is not your neighbor. The key to this slide is the fact that you are responsible for the output from your transmitter.
Right.
How far are you talking generally, normally, like feet, a long ways?
Yeah, we're talking feet. So if the RF exposure for my ground-mounted vertical at 10 meters at 500 watts, the closest I can safely get to it is about 6 feet. Okay?
And that's a lot of power on a dangerous frequency.
Yeah.
It still can get within 6
So
So-
if your only neighbors are 5
Right.
acres away.
Oh, God.
there's no worry about
You
it.
have zero issues.
You might have a VHF beam that's a 6-element, 8-element beam on VHF at 2 meters, okay? So you can do single sideband from here to Roseburg. And if you're pumping, say, 500 watts into that, the effective radiated power from the front of that beam is at what, 6 dB?
How many elements?
Say 6 elements.
Oh, you're gonna,
That's about 90.
that's about 9 dB, which is tripling it or doubling it 3 times. So 500 becomes 5 times, 500 becomes 1,000, becomes 2,000, becomes 4,000 watts going up.
So now you're talking about
Now you got
4,000 watts. Add VHF frequency where your body is more sensitive, and okay, maybe the minimum distance you can get to the antenna might be 100 feet. It does drop off to the square of the distance, so it dissipates pretty quick, but you still might not be able to get closer than 100 feet. But it's 60 feet in the air, so you've already got 60 feet cut off of it, and that means you might not be able to get any closer than 20 feet to the tower.
Plus, when you get the beam, we'll go into it in depth, but to get the power beam, where most of the power is going that way, it has to sacrifice from other directions, so all those other directions are
Very
closer and more safe.
Including
And so
down.
It can, in certain circumstances, you're probably never gonna see it, but where you got a beam and you just can't point it in that little area there where the neighbor's house is. But you're probably gonna be living in town and having a larger lot to never get into that kind of a situation. It's just, you're not gonna see it. But they want you to know that this stuff is out there, so it's
Yeah.
public test.
And then you are responsible for the output.
And, yeah, it's not your neighbor, it's you. There's other things your neighbor's responsible
So
for.
if you're just planning on the max, as long as you got that, then you're pretty much.
Right, so when I do my exposure calculations, it's every power level and every mode now. It's every mode at max power. Oh, I'm safe. I'm done. I don't have to do it for lower power.
So generally speaking, what's the farthest distance you need to be away then, 100 feet? or
No.
more?
No, it depends
I
entirely
have
on
an
frequency and
antenna
power level.
2 feet from me.
Also goes up, not just out. So
Right.
we're working on it this way.
Depends on the antenna. Most of it goes straight out with a vertical, but we have antennas that we design that go straight up. And we'll talk about those when we get the antennas.
But a beam antenna will squash it this way too.
Right, yes, we'll
So
squash it
if
this
you're
way.
down here below the antenna, you're not getting much of the radiation. So all of that will be calculated in when you plug in the numbers to calculate it. But generally, no, you're not going to have to worry about it.
Except for the test.